Hello and welcome to our lesson on translations of the sine and cosine functions. So let's recap so far what we've talked about in terms of transformations. We've already seen and reviewed how when we multiply a function by a negative, it reflects our graph over the x-axis. Oops. So if we multiply by a negative, we see all of our outputs have the opposite sign and we see the reflection over the x. So we have our parent, hopefully we're recognizing this, sine curve on the graph. There's one cycle if I start from here to here, but this whole thing, basically a little more than one cycle of our parent sine curve. So y equals the sine of x. And if I multiply by a negative, multiplying by a negative is going to reflect that over the x-axis, and this would be the result. That mirror image over the x-axis. So we know the sine curve starts at 0, but instead of going up to its max, it goes down to its min when we put that negative in there. So this one, again, being y equals negative sine of x. All right, and then we talked about what happens when we multiply by a constant, either multiplying the function by a constant or multiplying the x value by a constant. So if we multiply the function by a constant, then what happens is we are going to vertically stretch. We multiply the function, think about the function or function values being the y values, so we move vertically, which would be up and down along the y-axis. That would be basically what's happening in this picture. So if we look at this sine curve vertically, it's much taller than the other one. This one has an amplitude of 2 instead of having an amplitude of 1, and that's where we see that vertical stretch happening. So we see in this one, y would be equal to 2 times the sine of theta. So when we multiply, or x, sorry, whichever variable, doesn't really matter. When you multiply your function by a constant, it's going to either stretch it if it's bigger than 1 or compress if it's smaller than 1. So if we put a 1/2 out there, we would see that amplitude cut in half from our original 1. And then if we multiply, instead of the function by a constant, if we multiply x by a constant, then we are going to change horizontally along the x-axis, and hopefully that makes sense. So vertically, that's what we see happening here. Horizontally, that's the blue one in my picture here. If I multiply x by, let's say, a 2, then this picture is going to happen, where instead of just one cycle from 0 to 2 pi, we have 2 cycles fitting in there. So we're technically compressing horizontally. If you horizontally squish that graph, that's how you can squeeze 2 cycles in there. So with any other function, we would just call that a horizontal compression. But here, what it's directly affecting is our frequency. So this graph is y equals the sine of 2x. And that's when we horizontally stretch or compress. So this would be like the terminology that we would use in general in reference to any function. But when we vertically stretch or compress our graph of our trig function, what we're doing is affecting the amplitude. So we see a change in the amplitude here, and hopefully we're familiar with delta being a change in. And then this one, because we are going to horizontally stretch or compress, we're going to change the frequency or how many cycles or how much of a cycle we see from 0 to 2 pi. So here we see a change in the frequency. Okay, so that's the general terminology, but again, affecting our amplitude, our frequency. So those are things we've seen with other functions, we've seen with sine and cosine. Now let's talk about translations, the other types of transformations. So hopefully remember from college algebra, if we are to add to our function, right? So we have some function, and let's say we add 3 to it. Then if this is our original function, adding 3 just makes every single point on that graph shift up 3. So when we're adding to our function, again, to our function values, we're going to move vertically. So we're going to say that adding to our function, again, to our function, is going to shift us or translate us vertically. So again, we have some function and we add to it, or we could take the addition of that constant and then the function. So the order that we add, remember, that doesn't really matter. It's if we're adding, then it's specifically going to make our graph go up that many units. So we're going to go up, and we're just going to use the letter D, D units. And then if we were to subtract, which is just the same as adding a negative, then we're going to end up going down that many units. So D is going to be seen as our vertical translation or our vertical shift. And now we want to add that into the general form for our sine and cosine functions. So we've already talked about the parent being the sine of x. And then we talked about a plus bx being the general form, where we know this is going to change our amplitude and this is going to change our frequency, and that's what we just reviewed a few minutes ago. Now we're saying that if we also incorporate this, so we're going to add to our function, whether it's sine or cosine, then we're going to vertically shift. So d represents the vertical translation or the vertical shift in the graph. Okay, so how do we apply that to our graph? Like, I don't want to take every single point and have to necessarily shift it. I think the easiest thing to do is shift the midline, right? Normally our midline is at the x-axis. If we shift that midline and sort of use it like we would use the x-axis as a guide, we'll know the amplitude's going to go up or down from that midline. And then instead of having x-intercepts on the x-axis, we're going to have points on our midline. So let's do that here, okay? If we're looking at our first example, which we're going to try to graph over the interval from 0 to 2 pi, this plus 1 here, this positive 1, tells me that this entire graph is going to shift up 1. So what I'm going to do is take my midline and shift it up to positive 1. Remember, midline's normally on the x-axis. We're going to shift it. So I'm going to put my midline here. And then the rest of the work that I'm going to do is basically the same work I would normally do. Sine, we would say, starts at 0. Well, now it's going to start at our new 0, which has shifted up to 1. So it's going to start on our midline. It's going to end on the midline. It's going to hit the midline in the middle instead of starting at 0, ending at 0, and hitting 0 in the middle. Okay? So I know my sine is going to start at, let's make the graph here, 1. And then remember, this is affecting our amplitude because we have a half there. Our amplitude is going to be a half. So from my starting point, I'd either go up or down. And because I have a negative, I know I'm going to go down. And then the period's not changing. There's no b in there other than 1, so we're still just going to be looking at one cycle from 0 to 2 pi. And then the range we'll do after we look at the graph. So I'm starting on my midline instead of starting at 0. I'm going to end on my midline instead of ending at 0. And in the middle, I'm going to hit that midline as well. And then in between those, normally we'd say max and min, and that's still true, but it's not going to exactly be a half because we've shifted. So I want the amplitude to be a half. So when I go, remember, down from my starting point, I'm going to go down to, a half of a unit. So this is 1, 2, 3, 4, 5. I'm going to go right in the middle there. So this is going to be down 1/2 from my midline. And then on the other side, in between the other two points on my midline, I want to go up a half of a unit. And that's going to put me there. And there it is. My one cycle, right, because my period didn't change, with an amplitude of a half. It's a sine curve that's going down from that start point, but everything in that graph has shifted up. Whoops, what am I doing? Trying to connect the dots here. Okay. So here, and boom. And now we can see our range has shifted. Our minimum now is going to be, oh, that's my eraser. Minimum now is going to be at positive 1/2, and the maximum now is at 1 plus the 1/2, which would actually be 3/2. So we're going to say our range goes from 1/2 to 1.5, which is 3/2. So that's the midline at 1 minus 1, which would be a half, and then plus 1, which would be 1.5 or 3/2. Okay? And remember, we have technology. We might as well use it to confirm that what we're doing is correct. So let's try it. If I have y equal to 1 minus 1/2 multiplied by the sine of x, is my graph looking good? Yeah, okay, looks just like what I put on the paper there. Minus some curvature issues of my drawing, but yeah, basically what we see in the picture. Okay, let's try it again. Let's do a cosine curve this time. Whoops, going a little ahead of myself. So we have, with this negative 4 here, where our graph is going to be shifting down 4. So d equals negative 4. Again, this is going to shift down 4 units. Okay, so what I want to do is shift my midline. Instead of my midline being on the x-axis, it's going to shift down here to negative 4. Then everything else I'm going to do is basically the same work. Okay, just using my midline like I would normally have used the x-axis. So my amplitude still going to be 1. Okay, I didn't change that one here. My period is going to change this time because now I got to fit in 2 cycles. So my period is the 2 pi divided into those 2 cycles, which is going to make it pi. So I got to fit 2 cycles in here, and then the range, we'll figure that out in just a second. So just like I normally would cosine, think about the blue line that I put here as my, like where I normally use my x-axis. Cosine, we say, starts at its maximum, but that's shifted now down 4. So instead of from 0 going up 1 to the maximum, we're going to go at negative 4 and up 1 to the maximum. So the maximum now is going to be here at negative 3. And then we start at the max, stop at the max, but remember, 1 cycle's got to fit into the 0 to pi window, and then the second cycle into the pi to 2 pi. I got to fit 2 of them in here. So I want to start and stop, at my maximum. In the middle, hit the minimum, which would be 1 below the midline. So remember, amplitude of 1, 1 above, 1 below. And then in between those is where we would normally have x-intercepts, but here we're just going to be hitting the midline. And then we're just going to repeat that. So midline, minimum, midline, maximum, and now we can connect. So we got 2 cycles, amplitude of 1, shift down 4 of our cosine curve. And now I can easily see my range. The lowest would be negative 5, the highest would be negative 3. So negative 5 to negative 3. And again, we could take that shift down 4, and since the amplitude is 1, we add 1 to get to the negative 3, and then we subtract 1 and we get to the negative 5. So we can use the amplitude and that shift to see the range, or just read that from the graph. Okay, so those are the vertical translations. I think they're the easier of the two. Shifting left and right gets a little bit more tricky than shifting up and down. So we're just moving the entire graph up and moving the entire graph down by using the midline as our reference. And remember, use a calculator to verify if you're not sure. Now let's look at the trickier one, in my opinion, the trickier one, which is the horizontal translations. When we add to our function, we're adding to y's, we're moving up and down along the y-axis. If we add to x, when we're adding to x instead, then that should make sense that we're going to translate horizontally along the x-axis. And this one is a little bit counterintuitive. So adding going up and subtracting going down to me makes perfect sense. But here when we add, we're going to go to the left, which is the negative direction. And when we subtract, we're going to go to the right, which is the positive direction. And that's because we need to offset. So think about this, minus 4 here. I need a positive 4 to offset and get me back to that 0. So I don't know if that makes sense, but again, subtracting 4 from any function would make everything in that function translate 4 units. So if this is my original function, again, subtract 4, everything moves to the left, to the right 4. And then if I was to take that original function and add 3, everything in that function is going to go to the left 3. Okay, so that's something, again, we've seen before in college algebra. Now we want to try to apply this to our trig functions. So we've seen A affect the amplitude. We've seen B affect the frequency. We know that D can shift us up or down. Now we're going to say C is going to shift us left or right. And so in trig functions, these horizontal translations, they get a special name. We call them a phase shift. So C is going to represent not just the horizontal shift, we're going to call it the phase shift as in our graph. So C represents the horizontal shift, which is a phase shift. Okay, so those are interchangeable words, but typically we will use the terminology phase shift. Okay, now something important to notice, which we'll come back to when we get to number 4, is the form that we have here, where b is outside of these parentheses. So we have like factored form in here. So b as a factor of x minus c, or and then x minus c as separate factor. I don't know if I said that right, but we'll come back to that in just a second. Okay, so let's look here first. We're going to try to graph again over the interval from 0 to 2 pi by including this phase shift. So this still affecting my amplitude, so I know the amplitude of this graph is going to be 3. I'm not shifting up or down, so my midline's not going to move. That's still going to be here. What's going to move in this, and I don't want to mess my picture up too badly, but that's not moving, so I can still use the x-axis the way I would normally use the x-axis. Okay, and I don't have anything other than 1 in here for b, so my period is still going to be 2 pi, but now I have this phase shift. This minus 1/4 in here says that everything in my normal graph has to go to the right pi over 4 units. Okay, so what I'm going to do in this time, instead of shifting my midline and using that as a reference, I'm going to shift the y-axis. Okay, normally we're starting on the y-axis. Normally we start at the origin, right? If I go up or down, then I move the midline. Now if I want to go left or right, I'm going to shift what I'm normally using as my y-axis. So instead of starting at 0 there, if I have to go to the right pi over 4, then I'm going to go, so pi over 4, got to think about how much that is first of all. Pi over 4, that's like 1/4 of the pi. So here's my 1 pi, here's my half pi. This would be 1/4 of the pi. I want to shift there. So instead of starting on the y-axis, I'm going to start here. And when I say here, I mean pi over 4. Maybe I should just put that on the axis. So this is pi over 4 radians. Okay, so this is a sine curve. Sine starts at 0. It's just going to, instead of starting at 0, 0, it's going to start at pi over 4, 0. And then it also ends at 0. Now our ending isn't going to be at 2 pi this time. It's going to be pi over 4 units after it. So my ending is going to actually go beyond my 2 pi. And then in the middle I hit 0 again. So in the middle is normally pi, but it's pi over 4 after that. And then in between those zeros is where we hit our maxes and mins. And there's no reflection here, so we're going to go up to our max, which is going to be 3. So in between, normally at pi over 2, now shifted over, means our 3 is going to be here. And then normally we're at 3 pi over 2. Let's shift over and make our minimum negative 3 here. And now we can connect. And there we have it. So if I say graph from 0 to 2 pi, technically I did a little more graph than I need. Technically the only part of the graph, well, and actually we should backtrack this a little bit. 0 to 2 pi, I should be including this little portion too is going to continue this way, right? The technical part of the picture that I'm looking for is over the interval from 0 to 2 pi corresponds with all of this graph. But if you went a little further, I'm not going to mark you off for that. And sometimes it's just easier to finish out that cycle than to just kind of leave it hanging. Okay, the key is where are you starting? Okay, if you're shifting up or down, move the midline and use that as your reference. If you're shifting left or right, let's make a vertical reference line for ourselves and use it the same way we would use the y-axis as our start. Okay, so let's try it again. Let's see on this one. I want to go back to this form. That's important, okay? When we're looking at this, I can't just take this as b unless it's in this factored form. So in order for me to see b and c separately, I'm going to have to factor what I have in the parentheses here. And I don't know how long it's been since you've factored, but let me just go away for a second. So if I was asking you to factor, let's say 3x plus 12, you're looking for the common factor. In this case, it's 3. And when we factor that out, it's a process of division. So 3 divided by 3 would put a 1 in front of the x, and then 12 divided by 3 would put a 4 here, right? That's the same thing that we're going to do in these problems if there is a coefficient of x other than 1. So if we have something like, let's just say 3x, and then there's some phase shift. We see like a, let's just say like there's a pi here, okay, instead of a 12. Any coefficient other than 1, we're going to want to factor that out. So if that's a 3, we're going to factor out a 3. And when we factor it out, it's division just like it is here. So that would put a 1x here, which is what I want for my general form. And then I also have to divide this by 3. So then I can see my phase shift would be pi over 3. Or let's say I had like, I don't know, 2x minus pi over 4. It looks like this is b and this is my phase shift, but it's not because it's not in that standard or general form. So I would factor out the 2 to make x here with a coefficient of 1. And then if I divide pi over 4 by 2, then I end up with pi over 8. So pi over 4 divided by 2, which is 2 over 1, is really pi over 4 multiplied by 1 over 2. So that 2 is going to end up in that denominator. So we have pi over 8. And remember, you should be able to multiply this back out and get to what you started. So if I multiplied here, I would be back to the 1/4. Okay? So to get this in general form, the coefficient of x should be 1. If it's not, we were going to have to factor it. So I would start by rewriting this. We're looking here at y equal to negative 2 cosine of, I'm going to factor out the 2, and 2 divided by 2 would put a 1 in front of the x, which is what I want, minus, oh man, I don't know if I want to leave this as pi over 2, because then I'm going to have the exact same problem that I just had. Let's go ahead and change this to just a pi. I just want to rewrite this as 2x minus pi. Otherwise, we end up with the same thing that we just did in the last problem, and then there's a lack of variety. So let's pretend it was this, okay? Pretend that I had originally typed in 2x minus pi. So I still want to factor out the 2. Now, when I divide it away from the pi, it's going to leave me pi over 2. Okay, so there's the function that I'm looking at, where I can see my amplitude, I can see that I'm reflected, I can see the frequency, and I can see my phase shift. So all of it's there. I have my standard form. I have my not A right there. Sorry, A, B, and then C all lined up. Okay, so amplitude is going to be 2. Fix that. Period is 2 pi divided by b, which is 2 in this one, so that's going to be pi. And then phase shift is going to be pi over 2, again, to the right because it's being subtracted. Okay, so we're not shifting up or down on this one. We're just going to shift to the right. So I don't need to move the midline. I don't need to move the x-axis. I need to move, like what I'm using my y-axis as a reference, move that. And I want to go pi over 2 to the right. So instead of starting on the y-axis, I'm going to start at pi over 2. Okay, which means everything afterwards is going to shift to pi over 2. So this is cosine. Cosine's going to start normally at its maximum because it reflects. We're going to start at the minimum, which will be a negative 2. So on that line, we'll start at negative 2. And then normally we're going to end in the same place, but that ending is going to be, it's going to be like way over here, so it's kind of hard to see it. Maybe I should have made the graphic a little further, right? We want to shift pi over 2 from where we normally end, which is 2 pi. So we're going to end over there somewhere. Let me just sketch that in. And then in the middle is where we're going to do the minimum. So in the middle is going to be the 3 pi over 2. So that's where we're going to hit our, maximum in this case because we reflected. In between those is where we're going to have our zeros. So we're going to have a 0 here. We're going to have a 0. Oh, guys, you're letting me. Nobody's screaming at me like they wouldn't scream at me in the classroom, but I messed up. Almost messed up. Remember, our period's 1. We got to fit 2 cycles in here. So that means I actually have to fit 1 cycle in. If the period's pi, I got to fit 1 cycle in pi. So this is a half a pi, this is another pi. I got to fit 1 into this window here. So 1's going to go here, and 1's going to go here. So that makes that first one, again, start at the min, end at the min, but the min's going to be pi radians away. Maximum is going to be here. Whew, almost goofed that. Okay, and then in between those, we're going to hit our zeros. So those will be there, and then I just have to repeat that. So this would be a 0, and then this would be our max. And then I don't really have to go farther because technically we're at the 2 pi mark there, but technically this would be a 0, and then down here would be where we would end up. And I didn't include the 0 to 2 pi yet, so I don't technically need this. I can get rid of that. But I do need to finish the other direction because we're on the interval from 0 to 2 pi. So if I was to back this up, then following the pattern, back to 0 here, and then we're going to go back to the maximum here. So now I can sketch this out, connecting the dots. Easier said than done. And I think I say that every time. Sorry. And there we go. So we have covered everything over that 0 to pi. And yeah, just by using the phase shift as our reference, okay? And following the same patterns that we normally follow. So I can see, I don't know, partial cycles in there, but it's all good. All right, now remember, we can use technology to confirm. This would probably be a good one to check. -2, oops, let's start with the y equals. -2 cosine of, in parentheses, well, actually, let's leave it in the unfactored form, just in case, we make a mistake on that part. Let's put it in this form and see, does it look right? If we're just looking at 0, so 0 we had our maximum, pi over 2 we got our minimum, and then at pi, maximum, yeah, all looks good. And then at pi over 2 we ended at a maximum again. Yep, okay, so everything in the calculator is showing me that what we did on paper was correct. Alright, so here's where we separate the weak from the strong. No, here's the ultimate goal, is to be able to handle all of the transformations together. So if you're changing your frequency and your amplitude, and you have a phase shift, and you shift up or down, let's see if we can graph all of it, okay? So first I'm going to put this in the proper general form. That's my highlighter. So y equals -2 plus 3 sine of, this needs to be in factored form. Anytime this is in here, and there's a term being added or subtracted, we have to put this in factored form. Otherwise, we can't properly see our phase shift. So I'm going to make this 4 times, if I factor that 4 out, 4 divided by 4 is 1 in front of x, which is the goal, and pi divided by 4 would be pi over 4. So I have pi over 4 again, but this time it's adding, so this is good because it goes in a different direction. Alright, so amplitude, I can see right here, is going to be 3. And my period, based on this number, b, right, tells me I have to take my normal 2 pi and divide it into the 4 cycles. So my period is going to be pi over 2. So every pi over 2 radians, I have to finish a cycle of my sine curve. Phase shift is pi over 4. That's right here. Pi over 4, and this is going to be to the left this time. So let me say that. Left, pi over 4. Vertical shift, we've got one of those as well. There's a -2 out there. So we're going to go down 2. Domain, that's never going to change. These graphs go left and right forever, so that's going to be -infinity to infinity. And then the range, I can determine it by looking at the information. It's sometimes easier to read from the graph, but think about what's happening, okay? Our midline is going to -2. So we have like -2 here. And then our amplitude is 3. So I have to go up 3, and I have to go down 3 from -2. So if I add 3 from -2, that's going to put me up at +1. And if I subtract 3, that's going to take me down to -5. So my range should be from -5 to +1. But again, we could confirm that after we make the picture. Sometimes just a little easier than doing the actual math. Okay, now let's try to make the picture. So I want to take care of my translations first. So we know that we're going to shift down to -2. So my midline, I want to shift down to -2. And I also know I'm going to go to the left pi over 4. So left pi over 4, remember pi over 2 is here, pi over 4 is like 2 increments along my axis here. So it's going a little bit off the graph, but that's okay because I'm only supposed to be graphing from 0 to 2 pi. So it's actually going to be backed up here. I should have made this go a little further. So instead of starting like at the origin, I'm going to use this little intersection as my reference. Okay, so let's pretend that intersection is my origin. So this is a sine curve. It's going to start normally at 0, 0. Well, I have to shift pi over 4 to the left and then down 2, and that's going to be my new reference. Okay, so that's where I start. Sine's going to start there and end there. But remember, 4 cycles in this thing. So 1 cycle has to happen every pi over 2. So pi over 2 is, it's this much, okay? It's like 4 of the little tick marks on my graph. So every 4 of those, I gotta finish the cycle. So I want to start there, and then 1, 2, 3, 4, end there. And I gotta do that 4 times. Now remember, in the middle, we hit that midline as well. It's normally 0, but it's the midline in this case. And then in between those is where we get our maxes and our mins. Well, in this case, we have an amplitude of 3. And so in between those midline points that I made, I want to go up 3 units and then down 3 units. So I'm going to go up 3, and my axis is jumped a little, right? This is -2, so this is -1, 0, and then this is +1. So when I say go up 3, I have to go 1, 2, 3. So there's my max, and then my amplitude, again 3, so down in the middle of these other two, 1, 2, 3. So there's my 1 cycle with an amplitude of 3 that's shifted back and down. I just have to repeat that now. So this might be easier if I just draw one in. Alright, now I'm going to repeat it. So I got to start, and then 1, 2, 3, 4, stop. In the middle, hit that again. Max, min, in between, or amplitude of 3 in between. And I'm just going to get 4 of these in there. Okay, so start, in the middle, stop, in between those, up to 3, up 3 units, and then down 3 units. Okay, so I'm going to have to end up doing this multiple times. So we said 4 cycles from 0 to 2 pi, but this has shifted, so I'm going to get a little bit, I'm going to be a little bit off here, but I'm using my period of pi over 2 to make sure that this is correct. So again, pi over 2. So I'm going to end here. There's the middle. Up to 3. Down -3. Not to -3, but up 3 and down 3 from that midline. It looks, that was so bad. Okay, and then we're almost there. Remember, we just got to get to 2 pi. So that's going to be, this would be the next full cycle, but I don't have to go that far. So in between these, I want to hit that amplitude of 3 again. And then 2 pi can stop right there. So if I want to complete it, I wouldn't mark you off for completing it, but this is what your picture should look like, which is pretty intense. So let's go ahead and check. That's a lot going on in there. Y equals -2 plus 3 times the sine of 4x plus pi. Okay, that's a lot. And my calculator is so tiny. So it looks like we're going down. Oh, what did I do? 3 sine. Oh, I put a 1 there. It's a 2. I'm like, why doesn't this look the same? Okay, so this looks good. Maximums are at 1, which is what I have in there. Minimums at -5, which is what I have there. We're starting on the axis. Can we see that? Remember, the window I'm actually looking at is 0 to 2 pi. So on the axis, we're at -2. Yep, that looks right. That's my midline. And then I can try to check some other points here, but I want to see that pi over 2. Where am I ending? Well, there's right there, 15/8 pi. Pi over 2, 2 pi is where we end. And that's going to be, yeah, at -2. So at 2 pi, -2, that's a, okay, I can't get the cursor there, but it looks right. So what I'm seeing in the calculator does correspond with what we put on the paper, okay? So again, the key, if you're shifting up or down, shift your midline. If you're shifting left or right, shift what we normally use the y-axis as our reference, shift that, and then use that as your start. The rest of the work is pretty much the same. We're just not counting cycles in 0 to 2 pi because we shift sometimes. So you really want to rely on that period to make sure you're going the correct length for one cycle. Okay? Hopefully this is enough to get you going on your practice. As always, if you have questions, please reach out. But until next time, take care.